My name is Marina Matsudaria,
And my name is Marta Pawluczuk.
and we are part of the Harvard chapter of Engineers Without Borders. Our topic for this webinar is sustainability in materials. Our guiding question for our research was, how does material selection play a role in the sustainability of an EWB project? We chose to answer this question with the guideline of the 3 pillars of sustainability to see how the economic, environmental, and social factors all play a role in the sustainability of materials.
Oftentimes, when people think of sustainability, they only think of environmental sustainability. However, when we are looking at a sustainability of a project in a developing country, we have to consider economic, such as whether the community can afford to maintain the project, environmental, can the local environment handle this project, and social, whether the community accepts the project. It is only by considering the coexistence between these 3 factors can a project be successful.
So to start, let's look at some of the environmental factors to keep in mind as we decide on what materials to use. One of the things we need to keep in mind in material selection is how durable the materials will be against different and possibly increasingly more harsh weather events. It is vital that project teams research the historical and current weather patterns of a place before choosing materials for the project, and to keep in mind that some more traditional materials that are found in country are actually better at withstanding weather events than out-of-country materials.
Additionally, it is important to consider pollution and the environmental footprint a project could create. If we import materials from outside the region, there is more transportation time and fuel burned. Additionally, locally sourced materials may have the slight advantage of taking advantage of abundant unused resources around the local region, for example, using mud as bricks and insulators.
Now let's move on to economic factors. This quote from EWB-USA says that one of the biggest factors limiting the sustainability of a project is the funding necessary to maintain the infrastructure. This makes sense, since if a community cannot afford to maintain a project that EWB helps set up, the project will not last too long. That's why an EWB document on water sustainability from Volunteer Village claims that a project team should provide these 3 things for the community in which they're working: a good estimate for when parts break, how to obtain new parts, and the approximate cost of new parts.
Most housing developers insist on the use of conventional building materials and technologies, usually due to government regulations. These standards and regulations prevent the use of readily available local building materials that may also be cost-effective and environmentally friendly. On the contrary, however, countries with more relaxed regulations may also have lower quality materials. As we see in the diagram on the right, Africa loses $58 billion each year. A portion of that is due to the fact that many African countries, despite the fact that they are endowed with abundant natural resources that can meet their need for building materials production, depend largely on imported building materials and technologies. Building materials can make up to 70% of the cost of building a housing unit.
Lastly, let's look at some of the social factors that should impact our material selection for our projects. EWB-USA guidelines say that projects where the community have a strong sense of ownership will be much more likely to be sustainable into the future. This should be our main goal for our EWB projects, that the community will have some sort of investment in the project and will have more incentive to then operate and maintain it in the long run. Community ownership can look like a cash contribution to the project costs, the provision of labor and local materials, and helping in the selection of the technology used. There is a direct correlation with the lack of this community ownership and neglect of maintenance and repairs. This means, if we want a project to be sustainable, it is vital for the project to be managed by a village community of some sort so they feel a sense of ownership and empowerment with the project. You can see here that most of the national water policies' prerequisites for sustainable water supply are related to material selection. For instance, if we only choose out-of-country materials, how available and affordable will spare parts be for the community if something breaks? If we only choose materials that we are comfortable using, will the community have the capacity to maintain the system with the proper equipment and necessary materials? If not, the community could start to be less invested in the project and it will fail, as many have over time.
Additionally, materials such as timber and straw have been labeled as primitive and are stigmatized against using them. As a result, materials that could have many benefits, such as being local, cheap, and abundant, are neglected as viable options. In an ideal situation, when designing a project and selecting materials, we can have material that is local, cheap, and available, while also durable and high quality, with a little environmental negative impact and is socially accepted within the community. One example like this is the use of bamboo scaffolding in Hong Kong. It is local to the area as well as very effective. However, usually we cannot have it all, and therefore have to make trade-offs.
We want to give some examples of how to choose materials based off the factors we discussed for our chapter's EWB projects. First off, for well casing materials, we have been deciding between PVC piping or steel. Looking at the economic and social factors, we see that the PVC pipe is a good option since it is easy to work with, is lightweight, and commonly available in country, making it easier for communities to work with and therefore be more involved in the project. However, in terms of environmental factors, it is UV sensitive and will require a UV resistant paint covering and can crack at higher pressure. Steel piping, on the other hand, may be able to withstand temperate weather better since it is a stronger material and will have no UV degradation. However, it is more expensive, harder to work with without the proper cutting equipment, and is heavier to transport, making it a material that may be less sustainable in the long run with keeping the community involvement in mind. We want to quickly point out that there is no right or wrong answer in material selection like this. EWB's regulations on well casing material, for instance, say either steel or PVC can be chosen, since both have their advantages and disadvantages. They say that the choice of materials is largely dependent on what is available locally and the contractor is most comfortable working with, as long as the materials are resistant to corrosion and collapse of the borehole. So, we can see that it really is up to us, in the end, but that it's important to keep in mind all the factors we discussed. Our chapter's projects have also included water tank material selection. These are 4 options that we've had to consider: masonry, poured concrete, prefabricated, and furrow cement tanks. The masonry option is a strong tank that may be able to withstand harsh weather events, although it is subject to cracking, which will require some community maintenance. But since materials are available locally and most communities have the skill and knowledge to help construct and maintain a masonry tank, it is sustainable in a community involvement sense. Similarly, a poured concrete tank is a strong option, but may require more skilled workers and higher concrete quality. A prefabricated tank will have more environmental problems since it is lightweight and can be blown away, and will be more affected by UV rays. It is also not always available in country and is not as well known of a tank material, which may affect community involvement. However, it is a pretty easy tank to maintain once it's set up. A furrow cement tank is similar to a poured concrete and masonry tank in that it's strong but could crack, which would require maintenance and possibly more skilled workers.
While cement is used in practically every project, we will focus on what is available in Kenya. We will specifically look at ready mixed versus site mixed cement. For ready mixed cement, benefits can include the fact that it's made in a more controlled environment and therefore have more uniform quality. However, it is more costly as well as can be socially detrimental on the community since an outside company comes in and takes over the project, taking away community ownership. As for site mixed cement, while quality may vary more and separate purchases of materials is required, it doesn't require skilled workers and is something that the community can take part in helping with. Near Kibon, we found 2 cement brands, Simba Cement and Dumu Blue Cement. However, it was noted that Simba only has 2 strengths of cement, which is not a lot of variation. Additionally, those strengths were on the higher side, meaning they are more expensive. While in Kenya, cement is surprisingly cheap due to a sudden change in the economy a few years ago, in most countries that is something to consider when debating about buying locally or importing from elsewhere. Additionally, Dumu Blue has no documentation online, which makes us uncertain about what the quality of cement is and might make us wary of buying it.
In summary, it is evident that in choosing what materials to use for our EWB projects, it is so important to keep in mind all the economic, environmental, and social factors in sustainability. Again, there aren't any right or wrong answers to this, as long as each decision is well thought out. For instance, even though a chosen material may be newer to a community, with the proper training and a detailed O&M manual, the material can end up being more sustainable in the long run.
Here are the sources we used and where we got our photos from. Thank you for listening.